Okay, so to continue with our lesson on completing the square, the first page here is pretty much just going to review the steps of complete solving with the square that we had gone over yesterday. Getting the constant term alone on the right side of the equation. If you do have a number that is not a 1 in front of your x squared, you want to make sure you divide everything in your equation by that number to get rid of it. Then you're going to find half of that b value, square it, and add it to both sides. So you get the c value that makes it a perfect square trinomial. Factor it and solve. Okay, so just as a quick review, the first problem here, we would have to move that -4 to the other side, making that for a positive. Now you would use your perfect square trinomial. Half of 12 is 6. 6 squared is 36. Now you're able to factor this into the square of a binomial, x minus 6 squared, and then 40 over here. Now you can solve using your square roots. X minus 6 equals positive or negative, and then I would use my little factor tree here on the 40, getting me a 2 radical 10. Adding the 6 to the other side. 6 plus or minus 2 radical 10. All right, now the next example here is going to require you to divide everything by that 4 first. Now in the notes, they tell you to move the 8 over first. If you do move it over first or you divide first, it doesn't matter. It'll work either way. So if I divide it by my 4, I have x squared plus 10x minus 2. Of course, now I just move over the 2. If you moved the 8 over first, then when you divide, you still get the 2. So whichever. So of course, when I move my 2 over, it's a positive. Okay, so now 10 divided by 2 is 5. 5 squared is 25. We're going to factor this out now. So x plus 5 squared, and over here I have 27. Now I can use my square roots to solve. So x plus 5 equals positive or negative 3 radical 3. Move my 5 over. And then I have x equals -5 plus or minus 3 radical 3. Okay, so moving on, another thing that completing the square can be used for, in addition to solving quadratic equations, is putting a quadratic function in standard form, or that's in standard form, into vertex form. Now, when I see vertex form, for me, it makes it much easier to graph or to find the corresponding graph, things like that, to find the vertex, identify that. So it's very useful to have it in this form in many cases. Now, the steps for doing this are very similar. The ending is going to be a little bit different. So you just have to really be careful about the directions, because if we're doing a bunch of problems and putting them in vertex form, and then we have one where we have to solve, you may end up just getting in vertex form simply out of habit. So just be careful, make sure you know what your question is asking. So the beginning portion of this is going to be very similar. You're going to divide out that a, or that coefficient. You're going to move, now whether you move that c value over or not is really going to be optional for this one, because if you move it over, you're going to have to move it back anyway. For me, it helps me to move it over because I'm so used to doing that. If you don't want to move it over, you don't have to, personal preference. But for me, it makes it easier to factor. And then I just move the y back after. Make sure you're identifying the vertex at the end. Okay, so for example, for this one, I don't want this 22 here because I can't factor this with the 22. So if I move my 22 over, and I have the -22 over there, and I just pretend the y is not there for a little bit. Now I can figure out what that third number is. Okay, so I'm going to have to do 10 divided by 2, which is 5. 5 squared is 25. Okay, so now we're going to factor this out. X minus 5 squared, and 25 minus 22 is 3. Now, instead of square rooting both sides to solve like we were doing previously, instead we're going to just move this 3 back over to the other side. And we'll put my, whoops, hold on, messed up. X minus 5 squared, and then minus 3. Yeah, now there is my equation in vertex form. So now I can identify my vertex. Now, if you guys remember, this is your H, and this is your K. So the H was always the opposite sign because it's the number being subtracted. So that's actually going to be positive 5, and then your K, you always keep the sign. So negative 3. All right. So for this next one, we're going to move the 95 over temporarily, which makes it a negative. And then we have to figure out what's that number that I have to add to both sides. So half of 18 is 9. 9 squared is 81. So now this side here, this trinomial, I can easily factor into x plus 9 squared. I combine those two like terms there, which is negative 14. But then instead of square rooting to solve, I just move that 14 over. So y equals x plus 9 squared plus 14. And that is my equation in vertex form. And then, of course, to identify that vertex, the opposite sign from the 9 is negative 9, and then I have 14. So let's just keep practicing with a few more of these. Shut the door. Okay, so for this one here, we're going to move the 17 over. So we have a negative 17 on that side. And then we're going to figure out what is that number we have to add to both sides. Half of 8 is 4. 4 squared is 16. Now we have a perfect square trinomial, so to factor that, it's simply x minus 4 squared, and over here I get a negative 1 when I combine my like terms. Now I'm just going to bring this negative 1 back over to the other side, so I have y equals x minus 4 squared plus 1. Now with the vertex here, I'm going to have a positive 4 and a positive 1. All right, next one. We're moving the 3 over to the other side. X squared plus 3x, or sorry, plus 6x, and then we have to figure out what number goes in for my c. So half of 6 is 3, and 3 squared is 9. So now I can factor my trinomial into a square of a binomial, and 9 minus 3 is 6. Finally, I got to move my 6 back over to the other side to get it into vertex form, which is x plus 3 squared, and it'll be minus 6. Just make sure you do that sign change when you bring it back to the other side. And my vertex is negative 3 and negative 6. Okay, now this one you might notice that there's this f of x notation here. That's just function notation, but it doesn't change how you go about doing anything. It's just like having a y equals there. It doesn't change what you're actually doing. So we're still going to go ahead and move this. Now, again, this is one of those problems where you might say, wait a minute, half of 4 is 2 and 2 squared is 4, so why can't I just leave it? The problem is it's a negative 4, not a positive 4, so we still have to move it over because we actually need a positive 4 there, not a negative. So if we're going to add that positive 4 there, we have to make sure we move the original one over and we add the 4 on that side as well. So now we have x minus 2 squared, and on this side is 8. And now we can just move that 8 over, making it y equals x minus 2 squared minus 8. That's my answer in vertex form. And my vertex would be positive 2, negative 8. Okay, so the next 3 now are going to be a little bit different because you may have noticed that they do have these coefficients in front of the x squared. So that's going to require us to divide that out first. Now, it may or may not divide evenly. Doesn't matter. We still need to do that. So the first thing I'm going to do here is divide all of this by 3 so that I have x squared plus 2x plus 5. And now I'm going to move the 5 over, which is going to make me have a negative 5. Okay, and now we can fill in what does that c value have to be to make it a perfect square trinomial. Half of 2 is 1. 1 squared is 1. So we have x plus 1 squared, and over here I have a negative 4. Square rooting both sides. Oops, see, I actually got ahead of myself. We're not solving, so we don't need to square root, right? But that's a bad habit that a lot of us do. So then I would want to move this 4 over. Now, it doesn't matter if you want to do the next thing before or after, but you have to remember that because you divided out this 3, you actually have to multiply that 3 back to both sides. So 3 times negative 4 is actually going to be negative 12. So when I move that over to the other side, it's going to become a plus 12 like that. And that's a common step that a lot of people forget. And then, of course, my vertex would be negative 1 and 12. So when you do divide by that number in the front, when you're solving, it's not necessary anymore because you're trying to figure out what x equals. But when you're writing it in vertex form, you want to account for all of the things in the equation, so you have to multiply it back in. All right, we're going to do 2 more with those coefficients since that is usually the trickier types. Now this time we already have the c value moved over to the other side, so we don't have to worry about moving that over. We can just go right to the dividing. So we have x squared plus 14x. And then on the other side, we have negative 8 when we divide that. Now, of course, we still need to figure out what is the c value here that will work. So 14 divided by 2 is 7. And square it, we get 49. So now I have x plus 7 squared. And over here, if I subtract that, I get 41. Now again, we want to multiply this side by 3 and this side also by 3. So I get y equals 3 times x plus 7 squared. And then I want to move this over. I'm going to get 123, but when I move it over, it'll be minus 123. My vertex will be negative 7, opposite sign on the h, and then negative 123. Okay, one more of these. This time we're dividing everything by a 2. So I have x squared plus 12x plus, and this time we get a decimal. So now I'm going to move that over. For me, it just helps to have it on the other side. So it's going to be negative 12.5 when I move it over. And then I have to figure out what I'm adding to each side to make this a perfect square trinomial. So half of 12 is 6, and 6 squared is 36. Now I can factor this trinomial, x plus 6 squared. On this side, when I subtract, I get 23.5. But before I bump it over, or after, you could do it then too, you have to multiply all of this by 2. So now I have y equals 2 times x plus 6 squared. 23.5 times 2 is going to be 47, but when you move it over, it's going to become a negative, so make sure you don't forget that. And then, of course, your vertex would be negative 6 and negative 47. And that's how you change an equation from standard form into vertex form. Now, lastly, what can you use this for? So if we had a geometry problem where you were given the area and you were given dimensions as expressions, you could sometimes use this method to help you solve for x and then therefore find the dimensions. So we'll do these 2 problems. So we know the area of a rectangle is length times width. So if we're given the area as 72 units squared, and we know the length and the width are 3x times x plus 2. So I'm going to simplify by distributing, so I can get rid of those parentheses, 3x squared plus 6x. And now before I do anything, I need to get rid of this 3 here, right? So I'm going to divide everything by that 3. So 3 goes into there. Let's see. 24 x squared plus 2x. Now at this point, if I figure out, well, what am I going to add to each side here? Half of 2 is 1, 1 squared is 1. So I have 25 equals, and now I can write this as x plus 1 squared. Now at this point, I don't want to put it in vertex form. I actually want to solve it, so I'm going to utilize those square roots. So when I square root the 25, I get plus or minus 5. Over here, I'm left with x plus 1. Subtract the 1. So x equals -1 plus or minus 5. Now be careful because you actually can figure out those two answers. -1 plus 5 would be 4, and -1 minus 5 would be -6. Now, because we're dealing with dimensions and measurement, a negative would not make logical sense, so our answer for x is going to be 4. And be careful because you're not finished. You have to plug that back in. So 3 times 4 would give you 12 units for this dimension, and 4 plus 2 would give you 6 units for the other dimension. Okay, and then finally, area of a triangle, half times base times height, 144 equals 1/2 times our base and our height. And it doesn't matter what order you put them in, because remember with multiplication properties, you can multiply them in any order. So for me, as I simplify this, I can see right away that half of 2 is going to cancel out. So I have 144 equals, and then I'm going to distribute the rest here, x squared plus 10x. Now, if I add a number here, that would make that a perfect square trinomial, and then I could factor it. Half of 10 is 5. 5 squared is 25. So now I can write x plus 5 squared. Over here, I combine those, I get 169, and now I can solve using my square roots. Plus or minus 13 equals x plus 5. Subtract 5. So I have -5 plus or minus 13 for my two x's, which work out to be -5 plus 13 is +8, and -5 minus 13 is -18. Now, once again, it's measurement, dimension. We cannot have a negative. That doesn't make any sense logically, so it's got to be this 8 here. We're not done because it was asking for the dimension, so then we have to plug this 8 back in. So 2 times 8 would make this dimension 16, and 8 plus 10 would make the other one 18 units. And that's how you can use completing the square to help you solve problems like that.